All right, we're back, and second weekday stream here. Blah, blah, blah. Weekday stream, and we are still programming on an old computer, or rather, on an emulation of an old computer, and trying to write our own. Well, basically, it's sort of a backup application, I guess. But hey, and so we got so far that we can create a new folder in the backup destination, but somehow we didn't actually manage to create copies of, like, we created empty files instead of actually copying their contents over. And hi Ada, how's it going? I hope you're having a good week so far. I hope you've all got your goodies from your advent calendars. So let's have a peek, I guess, at what our program looks like so far. So far it looks like this. So this is one folder of one of our programs. As you see, it kind of shows us limited icons that we faked using our own custom font, because this is all a text field and HyperCard wasn't able to put icons on a line in a text field. And I actually realized I think I should move them all down by 1 pixel or so, so that they don't hit the top of the field. Anyway, that's graphical details. Yeah. So if we now click this commit button, it should make a copy. But as we all know, despite it saying it was copying everything, it always created empty files. Yeah, they all say 0K. So something is still wrong there. So let's go back to our copy file native code plugin and have a look at our code with a fresh mind. Oh, and by the way, sorry for those of you who watched yesterday's recordings that I had the camera on the left, so when I was typing new stuff, usually it was behind me. I've moved myself over now. I just realized I could actually move myself over just a tiny bit more. Hello? Yeah, like this should be good. All right. Tiny little jump. And this way you should see a little bit more of the actual code and windows and things. Okay, so don't drag yourself into the trash can. I love it because it's trash. There was actually, on macOS, there was a system extension that you see how the trash can, when there is something in it, the trash can kind of is open and full, and then you can say empty trash, and when I now click OK, you will see the icon change. So look in the lower right, and it will just become a thin trash can with the lid on it again. And in older versions of macOS, that the trash can would actually bulge in the middle instead. And anyway, so someone wrote a system extension that instead of changing the icon, or instead of just changing the icon, if you emptied the trash, it would actually show a little animation where Oscar the Grouch would pop out of the trash can and sing, "I love it because it's trash." So yeah, that just reminded me of that. I think I should probably look for if I can still find that extension and find a system version that runs in the emulator that works. Okay. So somehow it seems to be doing the stuff in chunks, and our output wrote blah 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 thing when you copy something. You'll see that this little message box window here. It should say something like wrote this many bytes. So if you look at that, it sometimes does 366, 512. So it seems to be doing something, seems to be reading some data, and so I'm kind of assuming that part of our file copying code, so the read part here, seems to be working. And then we say we write, and it seems to be saying it worked. And we're not getting any error codes, and bytes written is not a different number than bytes read. So it seems like we're able to do it, but it just doesn't happen. So the question remains, like, are we doing something wrong? So I guess the first thing we want to see is, let's see, when we're opening the files, we're usually not in this case, but it opens with a source file name and source file descriptor. So that looks right. Then we say we check for errors. Okay, that looks fine. And the second one we open, it's the same file name. That's, wait. Oh, we're opening the same file for reading and writing and just writing over itself. Okay. Easy. Okay, so here it should be destination vrefnum and destination directory ID. And this is why I should have not left the old names of vrefnum and dir ID in there, but should have actually named them source vrefnum and source dir ID. I'll actually do that now, just as penance, I guess. Source directory ID.
Uh-oh.
Okay. And then search for this as well. Source vrefnum. But it's, you know, if you update your names, it's much easier to find mistakes like that, because suddenly it would say source in the destination code. And that I would have immediately spotted, is my guess. Okay, so now we're opening the right file. So that copy and paste error is resolved. And now just to be sure, fswrite uses the dest file descriptor and fsread uses the source file descriptor. So that looks good. So build this. And now let's actually use rescopy and open, what is it, data xcopy file. Replace, yes. All right. And now?
Uh-oh.
Okay, it beeped.
Uh-oh.
Why does it beep? I guess we didn't have an error message or something. We're not showing one. So maybe I deleted the command that shows the actual error by accident. Failed to copy from to. No, there is an answer there. Let's see, maybe the copying using rescopy just didn't, you know, because basically the file is open and we had already used the native code plugin. So right, let's make sure we've done a build. And now copy,
Uh-oh.
replace, save, quit. And now try this again. All right. And now we look in the folder as list. That looks promising. Okay. Yeah, so we have sizes now. This looks like it might have worked, but although we don't need it because we're backing up to Windows, and Windows will ignore that data, I think we can now edit our file copying external to also use the right file type for the destination file and creator. So first, we need to go in the files. I think it's the files header. There is a call. I remember that from memory that it was called getfinfo. That, I guess, h getfinfo is the right one, because that's the one for hierarchical file system, and probably the just getfinfo, yeah, it only takes a volume refnum, not a directory idea, so that's for the old flat file system like we had it yesterday with the other calls. All right, so we found that call. If not, if you look here, I have inside Macintosh files, and I could have searched in that file information maybe, or you know, like maybe I would have searched for creator and checked. Let's see what I would have done. So FSP create is basically like hcreate is what we are calling. And I don't actually, I think we're wrapping around already. No, we're not. But no, we've wrapped around now. So maybe that's not in here. Interesting. There are some. Here is finfo. So the question is, why didn't we find finfo when hget finfo? Yeah. Set finfo. So the thing is, you know, like I remembered that it was called finfo, but I'm a bit surprised that it doesn't say creator anymore for the finfo. So the question is, maybe finfo is not actually documented in here because it's related to the Finder, and I think there is a separate book on the Finder interface. So that might be why I'm not seeing that in this documentation here. Yeah, I think we've wrapped around. So that's probably the problem. But anyway, we know what it is and how it works. So I can just use it directly. Hget finfo. Now, of course, we want the source vref num and the source dir id and the source file name, and we need a variable of type finfo. Initialize it to 0 just to be safe. And info. And now look back in files, I think is where it was. Let's see if we find the data structure there. Usually the headers are structured like the books. So given I was unable to find it, either it's just at the start. Oh, it's just at the start. Okay, and it's fd type and fd creator is what we are interested in. Where are you? No, here. Get finfo. We should probably handle errors. Error getting source file type. All right. So if something goes wrong, that's it. The hotspots on these, you might see that the cursor that you see is kind of skewed, distorted. That's because I have my windows set to show me larger cursors. And the way the emulator does it, they also get scaled up. Okay, file info fd type. And so the hotspot on these cursors is all over the place. Okay, now just have a quick check on hcreate, whether it was type creator or creator type. That's just so we don't creator type. Exactly the opposite of what I did. Good thing I checked. Okay, so now our copies should have the same type as the originals. Okay. And now we can quit this. Hopefully we won't. I probably just jinxed it by saying probably we won't need it anymore.
Uh-oh.
Replace the old version. And now make a commit. Oh, we will need it again, of course, because those progress messages are still there. All right, now let's look in here. Yes, they have the right types. And now let's look at the first one. Yep. Second one looks good. That's the implementation of all of these. That looks good. That looks promising. And this one should decompress, I guess. Yeah. So that's all good. And so now we have all these files in a way that we can check them in. So now the one type of file that I'm thinking about treating specially. Oh, I just realized we need to do two things to the copy files native code plugin. So first, as you may remember, on macOS 10, resource files were moved to the data fork. So you actually, just when you still needed resources, you didn't put them in the resource fork, which Windows didn't have, but rather it was just turned from something attached to every file was just turned into regular file format. So one of the things we prepared in our native code plugin in this Xcopy file thing is we added an attribute to say, I want you to copy the resource fork into the data fork. So that means for any resource file we encounter, we can actually transfer it into the data fork, so you can check it into Git without it just being an empty file. of course, what we want to eventually do with this tool is not just to generate commits on the Windows PC, which I haven't actually tested yet, I just realized, but also we want to be able to copy them back onto the Mac. So that means we need to be able to work in both directions. So I guess the first thing we will do is we will define an enum file copy mode, and we will say k file copy mode resource fork to data fork. Let's see. We should probably do the standard first. So data fork to data fork is 0. Then resource fork to data fork is 1. And I think I want to do this as a bit field. So 1 means source is resource fork. 2 means destination is resource fork. And now we can say source data fork to resource fork. And I think now we have all the variations. We can do data to resource, resource to data, data to data, and resource to resource. Okay. Enum, let's do that more symbolical bit. File copy mode bit, and say k source df bit equals 1 bit shifted by 0, which is what you usually write stuff like this by. No, source resource fork bit, and dest resource fork bit equals 1 shifted by 1. So that's the numbers 1 and 2. And then I can say source resource fork bit, source resource fork bit, and dest resource fork bit. And that in turn means I can set these, test for these separately, which will make my code easier. And now we go down, and we had a boolean here, res to data fork. We'll rename both of these. So this one we'll name, I think file copy mode is what we called it. Yeah. File copy mode string. And enum file copy mode data fork to data fork by default. All right, let's align all of that. And yes, I'm using tabs here, not spaces, so sue me. Everyone did at the time. All right. And now here, file copy mode string, and now if equals string res to data fork, then file copy mode equals k file copy mode rf to df, and now else if res to res fork, which we'll probably never use, then we'll do rf to rf. And then we'll do data to res fork. So that's df to rf. So res to data fork, res to res fork, data to res fork. So we have data to res, res to data, res to res if we ever wanted to just make an exact copy of a resource fork, which for this project will pretty much never happen. All right, what else? And I guess all other cases get mapped for data fork to data fork. Actually, let's hard code data to data fork. And be nitpicky else if not restore fork to data fork string empty, then we output an error. Unknown file copy mode expected what is it, curly bracket, where did I put my, no, there are here. This keyboard has, it's really cool, it's a mechanical keyboard, it's a DAS keyboard, and it has a volume control knob, which is really nice because you can really much more easily go like 10 levels up or 10 levels down quickly. And it has keyboard backlight, and what else did it do? I don't know. It has all the things I wished for at the time. Oh, and it's wired, so I don't have to constantly charge it or anything, or its Bluetooth connection drops out when the neighbor starts their microwave and I'm in the middle of a game and suddenly can't move anymore. But one thing that's a bit weird about it is that I think it's because of how the key switches work that light goes better through the top than through the bottom. So they put all the regular keys at the top, and when you press shift, those letters are printed on the bottom of the keycaps. And so I'm constantly looking at it and going like, where is the curly bracket? Oh, right, it's the one below the square bracket. Volume control for the mechanical typing sound. That would actually have been a cool feature, you know? Just going like, oh, I'm streaming. Let's turn down the volume on those keys. I want the clicky feel. I just don't want the noise. Okay, so res pipe data to res pipe data fork. All right. And now update the syntax. All right. And now we actually need to make it do this, right? So now that we've unpacked the flags and assigned their value to the file copy mode, we should... Okay, the get f info doesn't matter. There is only one, no matter which port, fork. But here, so first the source file here. If file copy mode and k file copy mode source RF bit is what I called it, I think.
Uh-oh.
What is it called? Just K source RF bit. Okay. Didn't actually use the full name. It should be safe enough here. Okay, source RF bit. And now we need to do the same for the destination. Dest RF bit else. It's funny how much you get used to auto indentation and all that stuff and then you miss it. On the other hand, it's also funny how much it comes back, the memory. Okay, let's see. Can we do hcreate? There should be an hcreate RF or something like that. So let's go in files, hcreate. Create R. Let's look for that. Oh, that's could be. That's probably in the resource manager. Okay. Include resources.h. Create res file takes a string. H create res file. Yeah. That's what we want. What's the difference here? Oh, I guess it's a... Interesting. In System 7 it's a trap, and in System 6 and before it's, I guess, some glue code. Fascinating. But anyway. Yeah, there was hcreate. Hi, Heretic Sin, by the way. Hcreate in files.h, although I don't know what I'm really talking about with programming anymore. Yeah, hcreate. The thing is, on the Mac, files have two so-called forks. So basically, every file has two contents. it has, you know, like in a text file, there is the data fork that is just the text. And then there is the resource fork. And just in theory, it's the same thing. You could put a second bit of text in there. But they actually designated it as a standard file format for containing resources, which are just little blocks of data. Kind of like a tiny file system in a file. So kind of you can have tiny simplified files in there. And that was used, for example, to store localizable strings or icons and things like that, graphics, in certain file formats. And so my file copying code here has to be able to copy both the resource part and the data part. Metadata sometimes, probably, yeah, basically often as well. Like on a Mac, basically an executable program, like an application, was basically all in the resource fork originally. So there were code resources and there were resources describing each dialog window and things like that. But in documents, often it was just metadata. So for example, here, this file, I think if I open this with resEdit, I think it will actually contain, yeah, it contains two little resources. And those are, I can't really view them, but for example, it says Monaco, so that means it remembers the font used to display the source code. And I think it might also like remember the position of the window. I'd have to check. I don't know. So that was what some applications did. If they had like a standard file format, like a text file, they would just save some metadata in there, which was really useful. But for example, if I use, you know, in any application program, the resources were actually all the bits and pieces that make up the larger program. Okay, and now destination resource fork. So then we need to do hcreate res file and not create a data file, and we use, it just uses vrefnum directory ID file name. vrefnum directory ID file name. So now I need the documentation, because I suspect that I need to do hcreate and then hcreate res file. Oh, right, and resources is not in the file manager inside Macintosh, but rather, oh, I didn't, yeah, okay, but rather there is one. Oh, I don't actually have inside Macintosh for resources here. Is that more Macintosh Toolbox or Toolbox Essentials maybe? Let's see. I thought there was a separate one for the resource manager, but maybe that was just a chapter. Event menu, window manager, control manager, dialog manager, finder interface. Nope. That's Toolbox Essentials. So let's see, more Macintosh Toolbox. Resource Manager. Okay, so that's just a chapter in there. So now let's search for hcreate res file. Note that creating a resource fork does not automatically open it. Yeah, who cares? Okay. Let's see. The hcreate_res file procedure creates a file with an empty resource fork in the directory specified with vrefnum and directory ID. If no other file with the given name exists in the specified directory, hcreate_res file creates a resource file that is a resource fork. If a file with a specified name already exists and includes a resource fork with a resource map, hcreate_res file does nothing. If the data fork of the specified file already exists, but the file has zero-length resource fork, hcreate_res file creates an empty resource fork and a resource map for the file. Before you can work with a newly created file's resource fork, you must first use hopen_res file. Okay. So that means that actually I need to do hcreate either way. Because we want to create a file with the right type and creator code, and then optionally add a resource fork to it if the data fork is empty. So destination resource file and destination file, so we get separate error messages. That should be okay. And now, so this opens the source file, and now we need to do the same for the destination file. hopen, and hopenrf is exactly the same except for those two letters. And that of course needs to be the dest rf bit. So now what we do is we create the destination file, which gives it the right creator and type code. Either way, then if we're told that we're supposed to copy to the destination file's resource fork, then we call hcreate_res file on the same file, which adds a resource fork to it. And if we're told that the source is the resource fork, then we call hopenrf, otherwise we just call hopen. So now we should be able, and the same for the destination, then we open the resource fork or the data fork as needed. Good. So that means yeah, we're doing pretty much everything. Then we set the file position to 0, so to make sure we start at the start. And then we read it in 512 byte blocks. And now there's one clever thing I want to do, which is specific to HyperCard. And that is, so right now we've been sending a command to HyperCard that just printed some text in the message box. But what would be really cool is if we could show progress information for copying the file. And for that, we first need to figure out how to determine how long a file is. Let's see, is there any length information somewhere? Ideally, a single function call. Get f info get EOF. That looks good. Good that I remembered that. In standard C source code, there is no call to get the end of a file. So what you usually do is you open the file, then position your file read-write mark at the position 0 relative to the end. So that's the very end. And then you read the current read position back. And that gives you the length of the file. Which is always very annoying. Like one of the first utility functions I always wrote when I had to use standard C library file reading. But the classic Mac OS actually had this get EOF function. So I can actually pretty quickly here, once I have opened all the files, I should probably add some comments. I'm too lazy to actually break this out into functions, but extract xcommand parameters until here, convert paths to macOS data types, create destination file. These are not super good comments because you should see that by reading the code, but since it's so much code, I want to break it up a little to find my way around more easily. Now, open source and destination files. And we need long source file size. Make sure we start reading from the start. It's probably not needed. I think I added it when I thought this might be the reason for our file copying. But technically, I think HyperCard could have one of these files open, or another native code plugin maybe, and could have changed the read-write position. So I think it doesn't hurt leaving this in anyway. Determine size for progress display. So get EOF, or determine source file length. Oh wait, that's here. And excuse me, source file descriptor. Alright, and so now we handle the error here just by bailing out again. determining source file size. And I'm just remembering that I actually never checked whether this file copy code now works when I'm copying outside the emulator. So that will be the next step. Before that, we can't really celebrate that we found the file copying bug, because it might still be another one in there. Okay. Now, why am I doing this? Because I want to send progress information. So send HC message is a command that I can give HyperCard source code, so HyperTalk, a script, and send it to HyperCard itself to run. But what we really want is we want to send a message to the current card so that we can update some sort of progress display. And to do that, there is a separate callback command for HyperCard native code plugins. So we have, here is a bunch. So there is evaluate expression, which is like, you know, if you want to call a function basically, or have HyperCard do some mathematics for you. Usually, you know, in the native code, you can do most mathematics, and probably faster than HyperCard, because you know what data types you will be using. So this is mainly used to call a function the user provides for you or something. And then there is send HC message, which we used. There is run handler, which I've completely forgotten what it was. And there is send card message, which is actually what we want. And luckily that has the exact same parameters as send HC message, so we can just change the name. So where is it? Here, send card message. And now we need to change our source code. So first, x copy file progress, and then we append the bytes written, and then we do a comma. And as the second parameter, let's group those two together, num2string and append string. We do the source file length. And so what this should do is it should send a message named xCopyFileProgress to the current card with the current value and the maximum value of the current copying process, so that it should send to the current card, which in turn should mean, so let's Oh, I didn't rename these. File copy mode, not rest to data fork string. What's here? Oh, extra comma. Most modern compilers will in an enum accept that there is an extra comma. Some will put up a little warning, hey, you have an extra comma here. That's because if you check this into version control and you add a new line, you have to not only add your constant to this line, but you also have to edit the previous line. So every time you add a new constant to the end, the edit shows up as edited the last line and made it into 2 lines, which is kind of annoying. So that's why most modern compilers let you get away with an extra comma, and I'm so used to it. Oh, and hcreate res file does not actually have a return value. Oh, and why didn't anyone tell me that I still had Inside Macintosh open? I just wanted to open it up and realize it was still there. Okay, hcreate res file. Yeah, it's a procedure in Pascal, so that means it doesn't actually ever return. Oh, right, it doesn't return an error because it's a resource manager folder, and that means r equals res error. I think that's what it's called. Let's see, they should document it. Do they mention it here? Yeah, to check for errors, call the res error function described on page 151 for a description of hopenresfile function, blah, blah, blah. Okay, we're not really interested in hopenresfile though. Okay. So now what I'm doing here is I'm changing hcreate res file to instead of returning the error, which it doesn't, I get the error from res error and then I handle the error. And just because I forgot to unhide Inside Macintosh again, I should probably make that, like auto hide after a minute or something. What else did I change? Well, I added all sorts of comments here to see what code does. Right. What I changed was this down here. So instead of send hc message, just using the put command to put stuff into the message box, I'm actually taking the file size, which I'm determining up here, source file length, using get EOF on the source file descriptor. So now I'm sending an xcopy file progress message with the first parameter is the bytes written, and the second parameter is the source file length. So that means I have all the information to show a progress indicator for this file copying thing. And then I send that as a message. Okay, and now if we build... Why doesn't it know source file length? Did I call it something else? Source file size. Okay, let's call it length. Let's see if I've now got... No, I don't have a use of source file size. Good. Okay, let's get xcopy file and let's get cheap version control. Copy xcopy file. Place, save, and now in cheap version control. So now if I run this the first time, it should work the same as before, except that we don't get any progress information. Oops. All right, seems like that worked. Yes. And now we have to do it in the current cards. It would be a little more complicated to actually send this message to... Whoops, sorry, bumped the table there. To actually send this message to the button in which we are doing the file copying, which would of course be the ideal design. But sadly, an external command doesn't really get told what object it is being run from. So I guess I could probably use eval expression to find the target and then generate a message and send it using send-hc message, in which I say, in which I just say send this message to the target object. I'm actually tempted to find out if I can make that work, just because it would be so much better. The code would be, in the right place. But okay, let's do it with the card first. So on x copy file progress, current bytes, total bytes, and x copy file progress. And now we'll just abuse the message box again. Nothing gained for now, but we can make it cooler. And now let's do it in %. So let's say current bytes divided by total bytes. That gives us a number from 0 to 1. And since we want a percentage, let's do that times 100 and round, and then put a % behind it, and I think that would be fine. And now let's see what happens if we run this, if it actually gets triggered. Nope, it didn't. What's it? Did I misname the message? X copy file progress. Let's just put copying current bytes, total bytes. Okay, that works. So I guess we had a typo. All right. So what is wrong about that? Let's just say we'll call this ourselves. Oh, I know what the mistake was. Here should be an ampersand, not an asterisk. Yeah. Okay, and what we see is I don't think we're getting the final message yet. So what we do want is at the end of this loop, we make one more call to this code, which should... Oh no, I know why it didn't work. We need total bytes written. We don't need bytes written this time, because bytes written is always just the block size 512 bytes. Okay, so we need a variable. Long total bytes written equals 0. And now total bytes written equals bytes written. Oh, and we should probably handle the error first before we use whatever information it gave us. Not equals, but plus equals. And now total bytes written here. And now we should get to 100%. Okay. Xcopy file, cheap version control, copy over our new version. And now okay, that looks good. And now let's see, those still look okay. So now first, before we get any more into prettifying this, we try it with the folder on my Windows PC. So this PC, E downloads. And now we commit. All right. I think that ran through, and now let's check here. Downloads. Do we have an here? That looks good, actually. And that is 16th is today, 18, 13, 36. Yeah, that sounds like it was a moment ago. So we can now actually back up this chunk. So now, two things we want to do. First, do some functionality. What the point behind doing this really is here. Here, that was needs compression. And now we do the same. Case equal stack. Stacks always need compression because they contain resources and data. Applications as well. Resource files. And I think the CodeWarrior projects, I actually don't remember. Let's see what they really look like on the inside. Get info, desktop, data, xcopy file, project. Let's see, it says a bunch of bytes in the resource fork and a bunch of bytes in the data fork. So we can't really just copy them over, we need to compress them. If they only had stuff in the resource fork, then I would have gone and said, hey, we do the same trick as with resource files and just swap them into the data fork. Into needs swap. And now we do put data to data fork into copy file mode. And now xcopy file source destination copy file mode. And now data to data fork into copy file mode. If needs swap, then put res to data fork into copy file mode. So that should work. Let's go back to our local hard drive just because it's easier to see. Press commit again. So this should behave exactly like before, because we don't have a resource file. Yes, okay. That looks like it's fine. Yeah, there's even stuff in them. All right, and now we have to, what do we want to do? Well, for one thing, we want to do progress information, but for the other, we want to add a resource file. Hello, Lucas, Look. Thank you for the follow. Lucas, Look. That's a very musical name. It sounds like a chorus, you know. Lucas, Look. Great. Love it. Hope you're doing well. Okay. Where were we? Is this a Linux? No, this... Well, what you're seeing on screen is Mac OS 9 running in emulation on a Windows PC, actually. So this is an operating system from, well, it depends. Like the original Mac OS is from 1984, and Mac OS 9 came out in the late 90s, I think. And in, I think, 2001 or something, it was discontinued. So that's what this is. Looks beautiful. Yeah, it's a I like the design. It's nice. It's one thing that it has over even over some modern operating systems is that it's so comparatively clear and readable. So, like a button has a border and has rounded corners, so you kind of generally know you can click something, even if they look different. Like these are the black and white HyperCard buttons, which of course don't quite look current. These are list header buttons, which of course also look slightly different. But in general, it kind of like everything that is clickable kind of looks a bit 3D, or at least a lot of it. And when you click something, you get some feedback, like it turns darker, and things like that. And yeah, it's fairly simple, but I mean, there's some things I miss in this operating system. Like, for example, you can only resize from the lower right corner. So if you want to make a window larger to the left, you have to move it over and then change its size and things like that. What I also really like, is you can see what the current window is. Because, like, in general, like, windows in the background kind of go this gray. They kind of disappear into the mist. And only the frontmost window is kind of fully, 3D borders and things like that. So it has some nice things. But, it's an old operating system. It has no memory protection. If I write code here that has a memory bug, then basically the entire computer shuts down. Best case. Worst case, it just, destroys data in one of the other programs I have open. So, yeah. It's a very, it was a much simpler time, basically. And of course, this, so I've blown it up to 720p so that you can at least read some of the text on stream. And, a 720p display at the time that, that macOS 9 was current was basically a huge display. Things like that, so it's just, it feels a little decadent. It is a bit more pleasant to use than it may have been at the time, At that time, I guess 1024 by 768 was kind of was towards the end of macOS 10. That was kind of getting to be the normal size that application developers would design for. But others, yeah, it was just different. They wouldn't have been widescreen resolutions back then. Yeah, as well. Most were 4:3, not 16:9. So that as well. Although I think the Power Books, I think they had 16:10 displays. Or did they? No, actually, I think they were still 4:3. You're right. 1024 by 768, yeah, would probably be standard in 99, 2001. I think, like, if you were someone who got, like, the expensive display, you would have gotten I don't know, what was it? like 900 pixel high screen, maybe. But I don't know. But anyway, I mean, theoretically, I could make this display really huge in this emulator because the way the software is designed, basically all screens together can be about 32,000 by 32,000 pixels in size. Let's say 15,000 by 15,000, just because, you know, if you move a window close to the edge or something, so that, you know, like if you do something like this and your display is 32,760 pixels large, then the right edge of this window would be outside the valid numbers for the coordinates. So there would probably something bad would have happened then. But, you know, that's crazy huge. I mean, this, like most modern screens are. I mean, the screen in front of me is a 4K screen, so that's. Don't even know what numbers that's. 4,000 is somewhere involved there, of course. But, you know, like, so we're still far from 30,000. Maybe 10,000 pixels because both sides of screen. No, it's a signed short integer, 2 bytes. So 65,000 is like the total number range. For negative numbers, you have 32,000, and for positive numbers, you have 32,000. So, that shouldn't be a problem. But since the menu bar was always at the 0, 0 point, basically the right edge is the dangerous one. And the left edge could just go minus. So no matter how big your... Well, if you had a second screen to the left of the menu bar, then that would have negative x coordinates, of course. So there... I guess if your rightmost screen was the one with the menu bar, then you would still, you know, like run into trouble about 30,000 pixels to the left. But, you know, even for today's displays, you know, usually a computer has like 3, maybe 6 displays. If these have 4,000, so that would be 24,000. So we would be getting close to the limits. I mean, I remember many programs wrote their own scrolling routines because their content could be taller than 30,000 pixels. Like, you know, if you had a database, for instance, or something, and then they would kind of use longs, so they have 4 billion as their value range, and would then, when displaying it on screen, say, okay, now you can only see these 50 items, so only those coordinates need to be converted into 2-byte coordinates and things like that. So that was kind of a sign of distinction of many, you know, list classes or database classes or text editor classes. Could they deal with that much content? But like actually on a display at the same time, not as much of a problem. Alright, so we wanted to do a progress bar. So as you might see, we have buttons, we have text fields, and we have a bunch of pixel drawing tools. So how do we do a progress bar? Short answer is you do it yourself because you can't. Long answer is, well, you use a button. So how do we do this? Well, a button can have, for example, a rectangle shape or a shadow shape. I think I'll go with rectangle for now. You can not show the name, and you can highlight it. Well, let's name this progress bar. So we say set highlight of card button progress bar to true. Oh, I put a space in there, didn't I? Yes. And so now we have a black box that we can move around. Now, special trick. If a black box for a progress bar doesn't look nice enough for you, you can disable your button. And then you see you get a black outline, but you get gray in the middle. If you want it completely gray, you can also switch it to opaque, which removes the outline. So you could have a progress bar that is a gray fill. I actually like the black version pretty well. So let's go back to that. And let's make it like this. I think that's okay. And put it here. So this area where we show status will fill to indicate how much we're copying, and that's the file count field. So first we change our resize button and go and say file count. We actually have it here. And then we say set left of card button progress bar to left of card field file count. Let's say +1. I'm actually thinking whether I should leave a pixel free around the outside, but I think I won't. But I wanted inset by 1 because it's 1 pixel smaller here. I could have probably just have made it the full size. If the black and the black overlap, it makes no difference. But this way, if I want to switch it to gray, it will look right and we'll still have the outline. And now we say the top of card button progress bar to the top of card field file count +1. So that just puts it in the general correct position when we resize, just to make sure if that field somehow gets moved, the progress bar moves with it. And now the commit button should first show card button progress bar set with let's just call the other method So say X copy files progress 0, 100. So that means we should get a 0 length button once we implement that message. Then we show the card button progress bar, and here at the end we hide it again, so that way we show the copy progress. And this old stuff we can delete now. All right. And now we say card info. And this is the copy file progress message that our copy file external shows. You know what? Just so we see that it's all working correctly, let's turn this gray. So now you'll see how that progress will look. Okay, and now we do fraction put current progress total into progress fraction. So again, that's the number from 0 to 1 as a decimal number. And I think we should, I think it was max, right? Max 1, 2. Yeah. I'll do this maximum so I don't have to deal with if we have a 0 length file. Okay, now we have the fraction. And now we say and now it gets complicated, because if you remember, if I set the width of this button, it's anchored to the middle. So I'd have to move it to the left again. So what we do is we just manipulate the full rectangle. So put rectangle of card button progress bar into progress box. And now so the rectangle is left first, top second, right, then bottom. That was of course mirrored for you now. Oh, actually, I think it might have been right for you because my camera is mirrored. Ha! Is it? Yeah, this is my right hand. So it's mirrored, yeah. So it was actually right for you, yay. Okay, put width of card field file count -2, that's the 2 pixels for the black line, times progress fraction into progress width. And now put item 1 of progress box, so that's the left, plus progress width into item 3, which is the right hand side of progress box. And now set the rectangle of card button progress bar to progress box. So this should be it. And now if we click the button, we should see the progress bar. It will go across several times, once for each file. But we'll see. Oh, it's probably xcopy file progress. Yeah. Okay, that looks good. And now what else we can do is we can reuse this file count field and show the file name in it. So put last item of the path into file name. All right, and now go to the start, the path, the type. Okay, so that means at this point we have the file name, and now we say put file name into card field file count, and then at the end we should update file count. Put n files into card field file count and hide the progress bar again. So that should look a lot nicer and should show us the name. Of course, the name is underneath the progress bar in most cases. Okay, but that worked. Show card button progress bar, because there's one fancy thing we can do here. So we've done all the effects. It's as if I had a plan, which I actually hadn't. If we switch this to transparent, it will actually invert whatever is underneath it. If we now switch it back to enabled, we can actually read the text field underneath. So if we now run this, you see the file names quickly zipping through there. Ha! Isn't this cool? Okay, so we have a nice, sadly only per file progress display. I guess to make this really nice, we would have to, measure all the file sizes and add them up, which I think would be a job for another external command. So I don't really want to put that much effort in it. This is just a tool to let us do some other stuff after all. But anyway, we have half a dozen folders in here now, and the last one still has this in here. So now what we want to do is we want to see if we can create, we're using the X files folder as our test bed. So let's create a test resources rsrc. All right, and now we need to create some large resources. Thankfully, we have missed. So let's go here. Now that looks like a good bunch of picture resources. Not even sure how many of these we want to copy. Oh, caps lock doesn't do multiple selection. Shift does. That's what happens when you are not good at actually hitting keys on your keyboard without looking. Okay, so we have about 1.5 megabytes. These are kilobytes. Yeah, so 1.5 megabyte in the resource fork, none in the data fork. And so if this file copying code now works correctly and does the transfer from resource to data fork, the resulting file should be reversed. So first, update. Okay, and now we actually see it even gives us the icon we created for resource files. Good. Oh, it's calling stuff it. I forgot to remove it from the list. Okay. That, of course, is a wash. All right. So let's fix this. Here it is, rsrc. And while we're at it, we should probably fix the case-sensitive comparison. So let's put this case equal function, let's cut it and put it into the stack. And now, was it here? Yeah. If case equal char1 of type creator and apple. All right. Now replace the equal signs with commas. And now add the closing brackets. This is how you mass edit. All right. So now we shouldn't accidentally catch creator codes that aren't case sensitive. So that should be good. Oh, wait, we forgot one. All right. Good. we fixed that one. So oh, this file will probably be horribly broken now. Test resources. Let's see. No. Get file folder info. My guess is that the test resources file will be empty because we first compressed it, which turned it into a data fork only file. And then we told it to copy the resource fork over into the data fork, which is probably empty. Yeah, 0 bytes in data fork and resource fork. Worst possible outcome. Hello, my backup utility, it just lost your data.